just looking at the kind of general case for completing the square again, if you have an equation of the form x squared plus 2px plus q, when you complete the square, what you're doing is you're taking the x term, you're taking half the value, the x squared term, taking half the value of the x term, in this case half of 2p is just p, square the whole thing, then you minus the square of the value that you put into the bracket, and you plus the q, which is remaining. Okay, so that's the square, and that is half. Okay, so we'll go, just the more examples you do, it just becomes second nature. So here, what we're going to do is set up our bracket, x, take half of this term here, so minus 6, and when we're going to square minus 6, which becomes 36, so minus 6 squared plus 45, and remember this thing, people, even if it's a minus number here, you always minus whatever is in the bracket, so you always minus, so equals, this is squared here, minus 6 squared minus 36 plus 45. So this then becomes x minus 6 squared plus 9. Okay, so you want to sketch this. What's that going to look like? Well, where's it going to have? Is it going to be a maximum or minimum? Well, it's going to be a minimum because it's positive. Okay, so where's the minimum going to occur? Well, we know it's going to occur at 6 because we've got this negative 6 in here. And then we know it's going to be, well, the minimum value will occur when this is 0. So when this is 0, it's going to be 9. So up here it's going to be 9. And then the y-intercept, well, when x is 0, this is going to be 45. So this is going to be up here, 45. It's obviously not to scale, but so your graph, so your sketch is going to look something like this. Okay, that's it. Okay, let's do another example. Okay, so another example. When you have a coefficient or common factor, you want to take that common factor out because to simplify your expression at the beginning. So this becomes 4x plus 1 over 2. Okay, and then you want to start to complete the square. So this becomes x minus 2 squared minus the square of here, this, so which is minus 4 plus 1 over 2. And then you want to multiply this whole thing out. So 2x minus 2 all squared minus 8 plus 1, so equals 2x minus 2 squared minus 7. Okay, so if we sketch this graph, what's going to look like? Okay, so again, it's a minimum turning point, so it's going to have its minimum at -7 and 2. Minimum point here. Okay, and where is it going to cut the x-axis? Well, it's going to cut the x-axis at +1. Okay, it's going to cut it there. Okay, so it's going to look something like this. Okay, that's probably, I'm going to fudge this a bit so it looks better. So this is 2, that is -7, and that is +1. Again, these are just sketches. You'd usually be provided with some lined paper in the exam. So what about this one? Well, this one's a bit different to what we've seen before, isn't it? Because we've got this -x squared plus 2x plus 8. Okay, so this is different. This is going to be a negative, so it's going to be the other way around. So to simplify this, I'd take the negative out at the beginning, and then you're going to have to reverse the terms inside the bracket. Okay, because it just makes it easier to solve. this becomes minus x, what's half of 2, which is just 1, all squared. Okay, and then you take away the square of 1, which is just 1, so minus 1 minus 8, okay, and then you multiply back through by that minus, so this comes minus x 1 squared, and then minus 8 minus 1, which is 9, but this then becomes plus 9. Okay, you want to keep this negative term to the squared term here, because that gives you the shape of the parabola. Okay, so what's this one going to look like? Well, we've got a maximum turning point at 1, 9. So here, that's our maximum turning point, because we know it's a maximum because it's this negative, so it's going to be negative. And then across the y-axis at 8. Okay, so it's going to be here at 8. Okay, so our parabola is going to look something like this.